right, so let's do one more example, finding a confidence interval for a mean. A random sample of 35 college students was asked how many movies they had seen in the last month. The sample mean was 4.14 movies with a standard deviation of 10.02. Construct a 90% confidence interval for the mean number of movies college students see per month. Okay, so our population is all college students. Our sample size was the 35 students sampled. Right, our sample mean was 4.14 movies. Our sample standard deviation was 10.02 movies. Our degrees of freedom, remember we subtract 1 from our sample size. So 35 minus 1 gives us 34. We are told to use a confidence level of 90%. Right? And what we want to know the confidence interval, which again is our sample mean, our x bar, plus or minus our margin of error. All right, so step 1, check our conditions. Again, we are going to assume they are already met. Again, it's really just a quick check that our sample size is large enough. 35 is bigger than 25, so we're good. All right, we're going to find our standard error estimate. So our S is 10.02 divided by our square root of 35. That gives us 1.694. Again, you can do this calculation by hand because it's quick and easy, or we can rely on StatCrunch to give that value to us as well. That's up to you. Find and interpret our interval. So again, remember when we're using StatCrunch, we are going to go to our T-Stats menu, and we're going to use our sample mean, our sample standard deviation, and our sample size. Right? So the 3 pieces of information listed right up here in our original problem are going to be used to find our confidence interval. In this particular case, notice that our confidence interval is 90%. So when we enter that into StatCrunch, we want to make sure that we change that to 90%. Right? So we do that, we select compute. We are going to get 1.28 to 7.00. Right? Our interpretation. Again, we start with our confidence level. We are 90% confident. That the mean number of movies seen by college students in a month is between 1.28 and 7.00 movies. Or we could round to 1 to 7. Just make sure as you're working through the problems you're rounding as you're being asked to. Now we're asked a couple of additional questions here. If we were asked to use the data to construct a 95% confidence interval, would the interval be wider or narrower than a 90% confidence interval? Why? If we remember back from chapter 7 when we were talking about confidence intervals, the larger the level of confidence, the wider the intervals. Right? So we would say a 95% confidence interval would be wider because it would have a larger margin of error. As confidence level increases, so does the width of the interval. Again, something that we saw back in chapter 7, which is worth mentioning again now. Right, what would be the effect of taking a larger sample on the width of an interval? If we take a larger sample, remember that the larger the sample gets, the smaller our standard error gets. So the standard error would be smaller. This means the margin of error would be smaller. And so the actual interval itself would also be smaller. So if we kind of summarize what we have down at the bottom, a larger confidence interval is going to give us a larger confidence level is going to give us a wider interval. Right? So larger confidence level, wider interval. Larger sample size is going to result in a smaller interval. Right? Larger sample size means smaller standard error, means smaller interval. Right? So as you're going through and you're working through some of the problems in section 9.3, you might be asked to compare some different things, thinking about what happens to either our level of confidence or the size of our sample.